Welcome to the deep dive. This is where we take the sources you send us, sift through them, and really try to pull out the key insights for you efficiently.
And today we're tackling Avalanche. We've got quite a mix news articles, a pretty dense technical paper, some community discussions you shared.
Yeah, quite the collection. So our mission, really, is to get a clear picture. What is Avalanche? How does it work under the hood? What makes it stand out, in the whole blockchain space? And what's its potential down the line?
Sounds good. Let's dive in.
Okay, so just to start, what are we looking at here?
Where the sources frame Avalanche as this high-performance, scalable, customizable, and secure platform. It launched back in 2020.
Right, by AVA Labs.
Okay.
And the founders were Emin Gunsayer, Kevin Seknicki, and Ted Yin.
Exactly. And there's a bit of interesting background on Sire. One source mentioned his work way back in 2003 on something called Karma.
Oh, yeah, I saw that. A virtual currency for peer-to-peer file sharing.
Right.
Quite early.
It is.
Yeah.
Sort of suggests a long-standing interest in these decentralized ideas, doesn't it?
Mm-hmm. So connecting that to Avalanche now, what are its main goals according to the materials?
They seem pretty ambitious. Building application-specific blockchains is a big one, both permissioned, like for private enterprise use, and permissionless.
Okay. And creating scalable dApps, decentralized applications.
That too. And developing complex digital assets with custom rules. They call them smart assets.
Smart assets. So the big picture aim is like a unified platform for creating, moving, trading digital stuff.
That's the core idea presented, yeah.
Yeah.
A unifying platform for digital assets.
Okay, so that leads us to the how. How does it actually work? Specifically, how do they agree on transactions? Because it's not Bitcoin's proof of work.
No, it's not. And it's different from typical proof of stake, too. This is probably Avalanche's most novel feature. It's consensus mechanism.
Right. How do they make sure everyone's on the same page without a central leader?
Well, one of your sources used a pretty good analogy. Imagine a huge group of friends, like 1,000 people, trying to decide on lunch, pizza or sandwiches.
Okay, I like that. Easier than blockchain terminology, so.
So instead of one person deciding, each node on the network asks a small random handful of other people what they prefer.
Ah, like a quick toll?
Exactly. So maybe you ask 10 friends and 7 say pizza. You'll probably start leaning towards pizza yourself.
Makes sense.
And this happens over and over really fast all across the network. Everyone's constantly doing these little random polls and adjusting their preference based on what the majority they just sampled said.
So it's not like one big vote, but lots of tiny quick checks?
Precisely. It's probabilistic. It doesn't guarantee agreement instantly, but through these rapid rounds of sampling, the whole network very, very quickly converges on one answer. Pizza wins. Or, the transaction is validated.
And the key is it's fast and doesn't need a leader.
That's the fundamental takeaway. Fast, leaderless, and resilient. It's a real departure from older models.
What stood out to me was the efficiency. They mentioned this Snow family of protocols. Snow, Snowflake, Snowball.
Avalanche uses Snowball, which gets an extra boost from using a directed acyclic graph, a DAG.
Right, the DAG, which helps process things in parallel, kind of, not just one after another.
You got it.
Yeah.
And importantly, no energy-guzzling proof-of-work mining. Once consensus is reached, the network just settles. They call it quiescent.
Quiescent, so it's not constantly burning energy like Bitcoin.
Correct. That's a big difference compared to Nakamoto consensus. And also different from classical consensus methods that often need to know all the participants up front. Avalanche's permissionless nodes can come and go.
And it's supposed to be quite robust, less prone to forks or splits than Bitcoin if the network gets messy.
That's the claim, yes. More resilient to network partitions and asynchronicity.
Okay, and this all ties back to speed, right? The low latency. The white paper mentioned this being crucial for, real-world business uses.
Absolutely. Things like trading or payments, they just can't wait minutes for confirmation. Avalanche aims for finality in about a second. That low latency is a direct result of the consensus.
Gotcha. So that's the consensus engine. How is the whole platform structured to actually use this? I saw mentions of different chains and subnets.
Right, the architecture. At the core, you have the primary network. That's where all the validators live, securing everything.
Okay.
And within that primary network, there are 3 main chains. First, the X chain or exchange chain.
X for exchange. Makes sense. That's for assets, creating and trading them.
Exactly. Creating, managing, trading assets. It uses that main Avalanche consensus we just discussed and a UTXO model, similar to Bitcoin's transaction model.
Okay, X chain for assets. What else?
Then you have the P chain, platform chain. This one's about coordinating the network itself.
Platform. So
Right.
managing validators, staking the AVAX token, that kind of stuff.
Precisely. staking, delegation, and crucially, creating and managing these things called subnets, which we'll get to.
And how does the P chain reach consensus?
It uses a variation called Snowman. It's still Avalanche consensus, but optimized for linear chains.
Hmm.
Also uses a UTXO model.
Interesting. And there are rules for validators, staking amounts.
Yeah, you need to stake at least 2,000 AVX, minimum 2 weeks, keep high uptime, around 80% mentioned. The rewards can be up to 7.65% annually, and transaction fees on the P chain, they get burned.
Burned. Okay. So X chain for assets, P chain for platform coordination.
Right.
What's the third one?
The C chain, contract chain. This one's really important for developers
Why is that?
because it's an instance of the Ethereum virtual machine, the EVM.
Ah, so it can run Ethereum smart contracts
Yeah.
and dApps built for Ethereum.
Exactly. It uses the Snowman consensus like the P chain, but uses an account model like Ethereum. And it adopted EIP 155 Align for fees, which also involves burning some fees.
Wow, okay. So 3 chains, different jobs, different optimizations. But you mentioned subnets earlier.
Yeah.
What role do they play? How do you build on this?
Yeah, subnets are arguably where the real customization comes in. Think of them as custom-built blockchains within Avalanche. Yeah. Each subnet can validate specific sets of other blockchains. And the key is each subnet defines its own rules, its own virtual machine, its own fee structure, its own security model, its own networking, total flexibility.
So you could have a subnet optimized purely for gaming or one for specific financial regulations.
Exactly that. It allows for function-specific sharding, essentially. If different subnets aren't touching the same data, they can run completely in parallel. Huge scalability potential.
And there's an incentive program for this, Multiverse.
Right, the Avalanche Multiverse. Up to $290 million in AVAX earmarked to encourage subnet development in areas like gaming, DeFi, NFTs, institutional uses.
They're really pushing this model. Can subnets use different VMs, not just the EVM?
The potential is there, yes. The paper mentioned possibilities like Solidity plus DAML, WASM.
Yeah.
It opens things up for different developer communities. There's even mention of an Ethereum subnet, like a spoon of Ethereum to interact with existing ETH contracts.
A spoon. Okay. And how do these subnets talk to each other? Is it easy to move assets between them?
That's where technologies like Teleporter and Avalanche Warp messaging come in. They're designed to make it smoother for developers to move tokens, NFTs, even Oracle data between different subnets, trying to avoid those siloed ecosystems you sometimes see.
Makes sense. They want an interconnected network, not just isolated chains. Okay, so what powers all this? The AVAX token, right?
Yep, AVAX is central. Its main job is staking, securing the network. Validators stake it. Others can delegate their stake.
Okay, security. What else?
It's used for peer-to-peer payments,
Yeah.
benefiting from that speed and low fees we talked about.
Right.
It's also the governance token. AVAX holders get to vote on key network parameters.
Like what?
Things like the minimum staking amount, the rate new AVAX is minted, other economic rules, and of course it's used to pay transaction fees.
And those fees get burned, you mentioned, on all chains or just PNC?
The sources specify P-chain and C-chain fees are burned. That burning mechanism reduces the total supply over time. Could increase scarcity.
Interesting economic model. Can it be used in DeFi too? Like collateral?
Absolutely. Collateral and DeFi apps minting NFTs,
Mm-hmm.
it's meant to be used across the ecosystem. The overall monetary policy seems to be about balancing the incentive to stake for security versus using AVAX for all these other services.
And the community votes on this balance through governance.
That's the idea. On-chain governance for those key decisions, ensuring staking rewards don't push the supply beyond its cap, which is capped at just under 716 million AVX, according to one source.
Okay, so a platform needs users and builders. How's the developer scene looking on Avalanche compared to, say, Ethereum?
Well, Ethereum obviously has the head start. Huge, mature ecosystem, tons of tools, libraries, you know the deal.
Yes, massive.
Avalanche's community is newer, but the sources suggest it's growing really fast. There seems to be an appeal for developers looking for that high performance and the flexibility that subnets offer.
So attracting builders who want something fresh, maybe more tailored.
Potentially, yeah. And we are seeing concrete use cases pop up.
Like,
Well, DeFi is a big one, obviously fits well. NFTs are also getting traction. They mentioned an Art Impact Fund, the ARR program, supporting specific artists. Web3 gaming is another area. Gunzilla Games using it for their off-the-grid title, handling Web3 wallets on the back end.
okay, so crypto native stuff. What about more traditional enterprise interests?
That's cropping up too. The California DMV example exploring digitizing card titles on Avalanche. That's pretty significant.
Wow, yeah.
Discussions about supply chain uses, like for a company the size of Costco, potentially benefiting from that kind of transparency.
And tokenizing real-world assets, RWAs.
That's definitely on the radar. Even niche things like initial litigation offerings, ILOs, were mentioned as a possibility.
Okay, diverse applications. And bridging to Ethereum is important here too, right? The AEB.
Crucial. The Avalanche Ethereum Bridge allows moving standard Ethereum tokens, ERC-20s, and NFTs, ERC-721s,
Mm,
back and forth. Interoperability is key.
definitely. So with all this activity, let's circle back to security. How robust is it really?
The consensus itself provides that probabilistic safety guarantee we talked about. The white paper argues it's resilient even against pretty powerful attackers, and that large-scale attacks would be economically crippling for the attacker.
And the proof of stake aspect, needing to lock up a lot of AVX.
Right, that large stake acts as a strong deterrent against misbehavior. Similar principle to Ethereum's POS, though the exact mechanics differ. Both require significant skin in the game.
I remember reading about some early academic paper pointing out a potential liveness issue, something called Glacier.
Yeah, that came up in one source. It seems that related to very early theoretical versions. The way Avalanche actually handles liveness in practice is different now, using something called virtuous frontiers in vote messages to ensure things keep moving.
Okay, good to know it was addressed. Now, performance numbers. The 2020 paper threw out some big figures, thousands of TPS, sub-second finality. How does that compare today or against competitors like Solana?
It's always tricky comparing testnet results from years ago to live networks. But Avalanche's approach is different from Solana's focus on raw speed on one chain. Avalanche gets its scalability more from the multi-chain, subnet design.
So, potentially distributing the load across many chains.
Exactly.
Yeah.
And it's still generally considered very fast with low latency compared to, say, Ethereum before its big upgrades. An interesting point was that Avalanche apparently achieves high throughput using smaller transaction batches than some others, which helps keep that latency low.
What about malicious actors? Can they slow things down?
The paper suggested that yes, misbehaving nodes can reduce throughput, but the impact seems somewhat proportional to how many bad actors there are. It doesn't seem like a small number can bring the whole thing screeching to a halt. It shows some resilience.
Okay. But no platform is perfect. Were there any risks highlighted in the materials?
Yes. Fundstrat pointed out several potential risks for you to be aware of. Things like Avalanche not hitting its roadmap targets, governance becoming too centralized or slow, developer interest waning.
Standard platform risks, really.
Pretty much. Also, lack of demand for the dApps built on it, fierce competition from other Layer 1s and Layer 2s, not generating enough fee revenue, general crypto market volatility, and of course the ever-present regulatory uncertainty.
Always important considerations. Okay, so wrapping this up, what are the main things you think our listeners should take away from this deep dive into Avalanche?
I'd say the key things are, it's a distinct platform, built on a novel consensus mechanism that's really fast and efficient. Its architecture, with the 3 core chains plus the highly customizable subnets, is core to its identity.
Right, that focus on scalability, customization through subnets, and the very low latency seem to be the big selling points.
Exactly. It's aiming to support a really broad range of applications and assets, trying to tackle some of the limitations seen in earlier blockchains.
Okay, so to leave you with something to think about, given Avalanche's whole architecture, especially this focus on customizable subnets, how might that approach really change the game for interconnected, specialized blockchains? What could that mean long-term for users, for developers, and for innovation in the Web3 world?